Hello everyone, welcome to my new video. So today we are going to add a new tool in our bag to solve coding questions more efficiently, and that is XOR. So let's see what XOR is. So XOR is a bitwise logical operator that returns false if both the bits are same and return 1 otherwise if both the bits are different. Let's see the table of XOR bitwise operator. So this is A, this is B, and here we are doing A XOR B. So this is the table of XOR bitwise operator. When the bits are same, we are going to see a 0 means false. But yeah, when the bits are different, we are seeing this 1, that is true. Similarly for this one, 1 0 is 1 and 1 1 is 0. You will get surprised after knowing the approaches that the XOR operator enables us to solve certain problems. Let's take an example. So here you have given an array of n-1 integers and the range is 1 to n, and you have to find missing number, and in this case the missing number is 2. How will you find? So let's check our method first. So method first is going to be, firstly we add all the numbers from 1 to n and add all the numbers from here and subtract those numbers from this one. Let's see a code. Firstly we are adding all the numbers from 1 to n and we are subtracting elements of array from this number, and in the end we are getting S1. So this is going to be like, if this is the array, if we add up all the numbers, it's going to be 1 plus 5 plus 2 plus 6 plus 4 minus 1 plus 2 plus 3 plus 4 plus 5 plus 6. So this is going to be 21 minus 18. The answer is going to be 3. So what we did, we added all the numbers from 1 to n and we subtracted all the numbers that are present in array. So after subtracting we get our missing number. Here the time complexity is going to be O of n. N is the size of the array, and space complexity is O of 1 because we are only using the single integer. So what's wrong with this method, with this solution? So we get integer overflow whenever the value of n is higher. So how can we resolve that issue? I'm going to use XOR. Firstly, I'm going to do XOR of 1 to n numbers, that is 1 XOR 2 XOR 3 XOR 4 XOR 5 XOR and 6, and I'm going to do XOR of the numbers that are integers that are present in array, that are, and in the end I'm going to do the XOR of these two numbers. If I'm supposing this one is x1 and this is x2, then I'm going to do x1 XOR x2. Now you're thinking like, how can we get our answer from this XOR value? So let's calculate what's going to be the XOR of this number and this number. So XOR of all these numbers is 1 1 1, and XOR of all these number is 1 0 0. Now this is 7 in decimal number and this is 4. Now when we do XOR of 7 and 4, that is going to be 1 1 1 and 1 0 0. So this is 0, this is 1, it means it's going to be 1. This is 1, this is 0, it's going to be 1. Now this is 1 and this is 1, they are same. This, so this is in decimal form, it's 3. So this one is the answer, right? So now in this case we are not going to get any integer overflow problem. Let's see a few properties of XOR operator. They are really very important properties of XOR. The first one is whenever we do XOR of a number with the same number, we are always going to get 0. It means if XOR of 2 with 2, we always get 0, or 29 XOR 29 will get 0. This is the first property. Second one, whenever we do XOR of a number with 0, we are always going to get the same number. It means if 29 XOR 0 will get 29. 47 XOR 0 will get 47. The last property, and that is XOR is associative and commutative, which means if we can swap the numbers, we will still get the same number, we will still get the same result. Or if we regroup the numbers, we will still get the same result, which means if A XOR B, I group them together and see, it's always going to give the same number, which is going which we get from this number. And if we even swap these numbers, we'll still get the same number. So XOR is commutative and associative. Thanks for watching the video, guys.